Okay, so let's do another example. Suppose that IQ scores are normally distributed with a mean of 100 and a standard deviation of 16. If your IQ is in the top 2% of the population, then you belong to a group called Mensa. The question here is, what is the minimum IQ required to be in Mensa? Now, I'm going to start by letting X denote IQ scores. Okay. We know that X is a normal variable, the mean of X, so the mean mu X is equal to 100, and the standard deviation sigma X is equal to 16. So then this information tells us that X is not the standard normal. Okay, because the mean is not zero, and the standard deviation is not 1. Okay. So this is gonna tell us that we cannot use the standard normal probability table right away to find probability for X. Okay. So let's look at the question. We want to find the minimum IQ required to be admitted to Mensa. Let me call that value X sub 0. So I'm going to let X sub 0 be the minimum IQ to be in Mensa. So the problem tells us that 2% of the observations are greater than or equal to X sub 0. Okay. How do I know this? Imagine this number line represents all the IQs of the population, right? And let's say X sub 0 is right about here. Then everybody in this part of the number line belongs to Mensa, right? Which means that they are in the top 2% of the population. Okay? And so 2% of the observations are going to be greater than or equal to X sub 0. Now then, that means that if a person is randomly picked, right, then the probability that his or her IQ is greater than or equal to X sub 0 is 2% or 0.02, right? Mathematically, that means that the probability that X is greater than or equal to X sub 0 is equal to 0.02. Okay, so I hope this makes sense, right? It's very important that you read a question and are able to set up the problem, right? So the idea is I let X sub 0 be the minimum IQ required to be in Mensa. But people with IQ greater than or equal to X sub 0 are in Mensa, right? Which consists of 2% of the population. Okay. That means that 2% of the IQ scores are greater than or equal to x sub 0, right? 2% of the observations, or in other words, 2% of the IQ scores. Okay? So if I randomly pick someone, then the probability that I pick a member of Mensa is going to be 2%, and so the probability that x is greater than or equal to x sub 0 is 0.02. Okay? So now let's see. We have the probability that x is greater than or equal to x sub 0 is 0.02. We know that x is not the standard normal, so we want to standardize this, right? We do that by taking x, subtract the mean of x, and divide it by the standard deviation of x. We do that to x, and so you also want to do it to x sub 0. So now we know that this becomes z, right? That's the definition. Here we have mu of x, which is 100, and sigma of x is 16. So this is x sub 0 minus 100 divided by 16 is equal to 0.02. I'm going to go ahead and let z sub 0 be equal to x sub 0 minus 100 over 16. Okay. That means that the probability that z is greater than or equal to z sub 0 is 0.02. Now, notice here that we have the probability in terms of greater than or equal to. This means that we cannot use the standard normal probabilities table right away. Okay. Why? Because the table gives the probability that x is less than or equal to x sub 0. Okay? So the inequality sign doesn't match. So what are we supposed to do? What we want to do is we want to take the complement. We want to flip the inequality sign, right? So this is just 1 minus the probability that z is less than or equal to z sub 0. Okay. This is according to the first rule when it comes to using the standard normal table. Okay. So now you have turned the problem into the probability that z is less than or equal to something. Okay. So let me go So I have turned the problem from the probability that z is greater than or equal to z sub 0 to one where we have the probability that z is less than or equal to z sub 0 equals 0.98. So what do we want to do now? We want to go to the standard normal table, find 0.98 in the interior. Of the table, then trace out horizontally and vertically to get z sub 0, right? Let me write here again, this is horizontally. So let's go ahead and do that. I'm gonna go to the positive side of my table. The idea is I want to look for 0.98. If 0.98 is not in the table, I want to go to the next closest thing. Okay. So if you look in the table, you're gonna see we're gonna have 0.9788, 0.9793, 0.9798, and then 0.9803. So 0.98 is right here somewhere, right? It's not in the table, so you want to go to the next closest thing, and the next closest thing to 0.98 is 0.9798. So if you trace out horizontally, you get 2.0, and if you trace vertically, you get 0.05. That means that if we go back to the problem here, the value of z sub 0 that satisfy this equation is 2.05. And by this equation, I'm talking about this one right here, right? So now what do we do next? We know that z sub 0 is just x sub 0 minus 100 divided by 16. So this is equal to x sub 0 minus 100 divided by 16. Let's go ahead and multiply 16 to both sides. So if you multiply 16 to both sides, this becomes 2.05 times 16, and then you add 100 to both sides. Right? And so if you do the math, you get 132.8. So the answer is that the minimum IQ score required to be in Mensa is 132.8. So in this video, we looked at another example where we are given the probability, and then we want to find the z value that gives us that probability. Okay. The difference between this video and the previous one is that in this example, we have to do an extra step, right? Which is to flip the inequality sign. So this extra step right here. The idea is we have a problem that is expressed as the probability that z is greater than or equal to z sub 0. And so in order to use a table, we need to flip the inequality sign, right? So we take the 1 minus.